module. So I'm going to start talking about automated testing today. When I spoke to you last week and gave you kind of an overview of the module, one of the points I made was that testing is a really important part of the Agile approach towards software development. Testing is something that we do throughout the development process. Therefore, it's a time-consuming task. So any time-consuming task associated with developing software, if you can automate it, then that's all the better. We don't want to do manual tasks repeatedly. Why not? Because manual tasks tend to be done by people, and people are error prone, and that's where problems arise. So if we can automate it and get the automation right, then rerunning that automation means it's going to be right every time. So if you go into that section, then I'm going to start talking about unit testing, although I'll give a slight overview first of automated testing in general. So behind this link here is the slides that I want to get through today. I probably won't get through all of them, but that's all right. When you're doing testing, it's often felt that you're better off testing somebody else's code rather than your own code. And that's because the kind of mindset that you have to have as a tester is, that's what I'm getting at down here. Your mindset is there are bugs in the software and my job as a tester is to find them, as opposed to using testing as a way of confirming to yourself that the software is fine. If you take the latter approach, then you don't tend to put the necessary thought into the testing that you're carrying out. Secondly, so what we'll find is that when I talk about automated testing, what we actually will be doing is writing testing code. So not only are you writing the application code, but you're also writing testing code. Now, writing any code is time consuming. So you'd wonder, what's the point in writing all this additional code? Well, the benefit is this notion of regression testing. When you write tests for a particular, let's say a particular feature within an application, you're obviously going to run those tests as you're developing that feature. But further down the line, when you're adding more features to the application, you want to make sure that the new features aren't breaking the existing features. How do you confirm that? Well, you rerun the same tests on those existing features to make sure that they haven't been broken by the new features. And so this idea of rerunning tests many times during the development process is what's referred to as regression testing. And that's the real payback when it comes to automated testing. You're not just running them once, you're running them many, many times. Most of what's on this slide, I'm assuming, is something that you already know. You've covered or talked about testing. It may well be way back in first year, but so what you will know is that there are essentially 4 levels of testing: unit, integration, system, and acceptance. Unit testing, as its name suggests, is where you're focused on testing a particular unit within an application. That usually corresponds to maybe a class, if it's a Java-based application. If it's a JavaScript where all you have are functions, then the unit will be a function. But either way, it's that the smallest unit possible, let's say, within an application, and you want to just test that unit initially. That's what we refer to as unit testing. Integration testing is more about making sure that if you've got any part of your application that is communicating with an external resource, be that a database or maybe an external server or a remote web API, then you want to make sure that your software is communicating or integrating with it correctly. That's what integration testing is focused on. The assumption is that once your unit tests are all running okay, then you can think about integration testing. You wouldn't start doing integration testing before you were happy that the particular units that are involved maybe in communicating with the external resource are working properly in isolation. System testing is where you are focused on testing the entire application as a single entity. And clearly, you wouldn't embark on system testing unless you were happy that your unit testing and your integration testing were all passing successfully. Fourthly is acceptance testing. Acceptance testing is really system testing, but it's carried out by the customer or the client that you're developing the application for. So I'm kind of assuming that you've heard at least these terms somewhere along the lines. Now, because ye are studying a module called Web App Development, then these kind of terms have slightly different names when you're testing a web application. And I'm only bringing these in because that's going to be the focus of any testing that you're going to do. So we still have unit testing. So the units will be, JavaScript functions or JavaScript classes if you're writing classes, which I can tell you you won't be. It'll just be functions. API testing is kind of the equivalent of integration testing, where you're ensuring that your web API is working properly and is communicating with presumably a database. End-to-end testing is where you're testing your entire web application, both the front end, the web API, and the database, all communicating with each other as one entity, i.e. from end to end. So end-to-end testing is really the equivalent of system testing in the upper list there. API testing is really kind of in between system testing and integration testing. It's not an exact match for one or the other. So these are the terms that I will be using, because testing is a topic that I'm going to come back to a number of times in this module. Initially, I'm going to just talk about unit testing, but later on, I'm going to come back and talk about API testing. And later on, then again, I'm going to talk about end-to-end testing. If you're developing software following an Agile approach, which is really what everybody is doing these days, then there are certain principles that need to apply. And I've kind of alluded to one or two of them at the very beginning. You don't want to be writing your testing code from scratch. You need to find some sort of tool, or more properly, a framework that will help you in developing your testing code. And we will be using testing frameworks, a number of them actually, as it turns out. Number two, all application code must have associated tests. That's a given. You never write a piece of software for an application without testing to make sure, without subjecting it to automated tests to ensure that that piece of software, additional piece of software, is working properly before you start integrating it into the entire application. So, and this really goes back to the point that I was talking about, that if it's the case that you must write tests for each piece of code in your application, then the actual sheer volume of test code is going to be quite significant. But that's the world we live in today. I mean, if you take shortcuts, then what's going to happen? What's going to happen is the software is going to crash. And where is it going to crash? When it's out being used by your customer or your client or your user. And clearly, we don't want that. Number three, I'm saying, obviously, bugs are going, despite all the testing that you might do during development, there are still bugs going to appear in your software, which you may identify during development or which may be identified subsequent to development. That's a reality as well. We're never going to get to the ideal space where we never finish up with a piece of, with an application that does not have bugs in it. If we do, then it's a very trivial application. So there are always going to be bugs found. Hopefully we find most of them during development, but whenever they arise, what's the first thing that you do? Obviously you fix the bug. And number two, you write a test to make sure that your fix is correct. So again, you're adding more tests even during your debugging phases or when you have to go into debugging mode. Test-driven development is, I'll talk about it a little bit. It's kind of a methodology that you're encouraged to follow. It's very difficult though for beginners. You'd have to practice it many times before you become comfortable with it. The essential point is, and it seems counterintuitive, the essential point is that you write a test before you develop a piece of software. So if I've been asked to implement, let's say, a method for a class, and I've been given the specification for that method, let's say that's my starting point. What's the first thing that I do? Well, the first thing you might tend to do is start writing the method. But test-driven development says the first thing you should do is start writing your testing code. You have enough information to do that because you have a specification for the method. You're told maybe what the method signature is, and that really is enough information to be able to write the tests. Clearly, you can't run the tests yet because you haven't developed the method, but it's this notion of writing tests before you write the piece of application code, i.e. the tests are driving your development. I'll give you an opportunity to practice that in the labs, and I'm sure people are going to say this doesn't make sense, and that's kind of how it seems initially, but if you step back from it, there is logic to it, all right, and it is practiced a lot in industry. So what's the upshot of all of these things, of all of these principles? These are the upshots here, hopefully. Fewer bugs, more maintainable code. The second point here, that the idea that you always have code that is working, because you're testing as you go along. So whatever amount of an application you currently have developed, then you know that that subset of the application that you have developed so far is functioning. Because how do we know that? Because we have loads of tests that we've written to prove to ourselves that it is functioning in the main. Okay, there may still be a bug or bugs in there, but we have a certain a volume of executing code. And that can mean then that you could actually demonstrate that functioning code to your customer or client, in the knowledge, of course, that it's only a skeleton of the end product. But customers are always interested in seeing, can I get a look at what the current state of the application is? And it's really, it kind of gives a good impression to your client or customer, the fact that you can demonstrate something to them at the drop of a hat almost. You don't need 2 or 3 weeks notice to do that, which would have been the old way. And you'd spend those 2 or 3 weeks leading up to showing the customer the current state of your application. You'd spend the 2 or 3 weeks trying to get rid of all the bugs that are in there because you haven't done sufficient testing or any testing potentially. Like the old way of doing things was that you did all of your testing after you did all of your development. And that was usually a very stressful period because it was only at the end of the development life cycle that you were finding all of the bugs. So there's less kind of pressure now in this agile approach towards developing based on all the things that I've just said to you. Regression testing, I've already mentioned what it is, right? And that's really the payback, because if you're writing all of this testing code, we haven't seen any of it so far, but take it from me that, in many cases, the volume of testing code is greater than the volume of application code. That will give you a sense of it. So you are writing a lot of additional code, quote unquote, but the benefit of it is that you are able to rerun those tests many, many times during the development lifecycle, and you're rerunning them, as I said, to reassure yourself that the features that you developed previously are still working after you've added new features. That's regression testing. So the value of them is derives from that. I'll just pause for a second. This is going to be a very talky type lecture now, very theoretical, but we have to cover the theory before we can start looking at any kind of practical sides. Just as open the floor to ye if you have any questions so far, be it specific to this, or maybe there's something more general that you wanted an opportunity to ask me. No? Okay. So we've got to essentially kind of develop or write tests. So are there any guidelines as to how we should design those tests? And that's what I'm getting at in this and the next slide, I think. Now, the starting point before you can write tests for any piece of software, the starting point has to be this, right? You have to have a clear specification of the software itself, be that a class, a method, a feature, doesn't matter whether we're talking about unit testing now or integration testing or system testing. You must have a specification, however that's documented. It's in English or whatever language. And it's a specification of the requirements of the behavior of that particular piece of software. So as I said, it could be a method or it could be a feature. That has to be the starting point. If you don't have that, then you're going nowhere. The second point I'm making here is that, you see, when we're writing tests, we write the tests against the specification, because the specification is the true statement of what the software should do or how it should behave. All the implementation is a statement of how it actually is, how that feature was implemented. So this is a truer statement of what the objective is. The specification is really what you need to focus on, and you write your tests against the specification. You do not write your tests by just examining the code, because quite often the code is an incorrect implementation of the specification. You know, that's why bugs arise, be that because the developer misunderstood the specification or whatever the cause, the reasoning behind it is. So you kind of ignore the implementation when you're developing tests, which seems odd, but that's the way you should approach it. You focus on the specification and you write your tests against the specification. Again, that's kind of slightly counterintuitive, but that's the way you're meant to approach it. And if you take that approach, then you will design better test cases than if you take the other approach being you just look at the application implementation and you write your tests against that. Here I'm saying that you write tests in terms of expectations. You know, if I've got a specification for a piece of software, then I can make certain statements about what I expect that piece of software to do for me. These are what we call expectations. And those expectations, we need some way of expressing them in our testing code. And we'll see how we do that later on. There are certain libraries that make it easy to express expectations, but you need to kind of get that term into your mind when we're talking about testing. So what does it say? Write tests in terms of the expectations of the target. The target is the piece of application software that you're currently testing. Again, this is another term that we use. The target's behavior for a given set of circumstances, or for given circumstances and specified inputs. So we've got the inputs to the piece of software, how we expect it to behave in terms of the response that it gives back to us, and that behavior in certain circumstances. The circumstances might be, you know, what's the current, if there's a database involved, for example, what is the current data in the database? That would be an example of circumstances. Or if there's some sort of global data structure that the target software is manipulating, what is the initial state of that global data structure? What has it been initialized to? These are all very important when you're writing tests. And here's kind of, an English expression of what I'm talking about. I expect to get result X when the input is Y and the database has data Z. Okay, so can we kind of express this kind of stuff in code? And we'll see that we can. A term test target I've just mentioned. So the target is the piece of application software that you're currently testing. So if you're doing unit testing, the target is usually either a function or a class. If you're doing system testing, then the target is your entire application. Obviously enough, I guess. Now, I'll just go off on a slight tangent for a second, but there's a rationale behind it, and we're still on this topic of how do we design good tests. And I'm saying you think in terms of user stories. I don't know if you've come across this term user stories before. It's not actually related to testing necessarily. It actually comes from the area of user requirements analysis. As you know, the very first thing you do if you're embarking on developing an application is you talk to the user and you try and extract from the users what requirements do they have of the application that they're looking for. And you document those requirements in a document called the user requirements specification. Now, it's felt that a good way of documenting those requirements is by writing these things called user stories. And user stories, there is a pattern or a format for writing good user stories, and it's this given, when, then pattern. So the suggestion is that your user requirements spec should have lots of user stories documented in it. And these user stories should be expressed following this approach here. Don't know if you've come across that before or not, but there you go. So this given, when, then is, the given is referring to, well, what is the context or circumstances or current state of the application. And this kind of relates back to my previous slide where I was talking about, if I just go back for a second, I was talking about here, circumstances. So given is stating what's the current context. When is expressing what action is the user going to carry out on the application. And then is expressing what should be the behavior or response of the application for a given set of inputs and a given context. Examples always help us, I hope. So here's a very simple example of a user story. Is there more than one? Is it? Yeah. Of a user story for, let's say, a banking application. And, okay, I'll just read it with you, but you can read yourselves. Given my bank account is in credit, so that's the context or the circumstances. That's the starting point. When I attempt to withdraw an amount less than my credit limit and less than the balance, the current balance. So that's the inputs that I'm going to provide to my application. And here's the expected behavior or outcome, which you can read. I'm not going to read it for you. So that's a typical kind of user story expressed following this given, when, then pattern. And for this particular aspect of, let's say, our banking application, there are a number of variations of this. Like if I was to say the starting point is given my bank account is in credit, when I attempt to withdraw an amount greater than my credit limit and my bank account has that amount in it, then what should happen? Well, you go back to the user, or sorry, you go back to the bank themselves, and I suppose to say to them, well, how do you want the application to behave in that case? Another scenario would be when I want to withdraw an amount less than my credit limit, but greater than my current balance. back to the bank and say, well, how do you want it to behave? So you're writing all of these user stories to make sure that you as the developer have a full understanding of the requirements that the user has, i.e. the bank, of the application that you're going to develop for them. So that's user stories, right? It's part of the whole user requirements analysis. Just going to pause again for a second to make sure people are following along with what I'm getting at here. I've certainly moved away from testing for a minute, but we'll come back to it in the next slide. Is there any clarification anybody wants on what I'm talking about there on this slide? No? Here's a few more user stories, and you can read through those yourselves. These user stories seem to be more at the application kind of system level, whereas the one on the previous slide was more focused on a particular feature, let's say within our banking environment. These are all very trivial ones as well, as it turns out. Now we're back to, sorry, if I go back, we're back to unit testing, our testing and designing good tests. And in particular, I'm just narrowing into unit tests at this stage. And I'm saying that this given when then structure, that can actually be quite useful when you're trying to come up with good tests for a unit within your application, or indeed when you're doing system testing. It's also a good structure to follow when you're writing system tests. And, you know, I'm giving you examples, and again, the examples, maybe these that are slightly trivial, but hopefully they prove the point that I'm trying to make. So let's suppose I've got a small method in, let's say, a college administration system, and there is a method that takes an array of students, and it's meant to sort them and return the sorted array back to me. So if I want to test that particular method, then these are two, I would argue, sensible tests that I should implement somehow. And I'm expressing the tests in English for now anyway, using this given, when, then format. And you can just skim over those two yourselves for a second. I put a question mark here, actually. What am I saying here? Given the array has no student objects, so if I pass an empty array of objects, student objects, to my method, which could arise, you know, when we sort these by name, then what should happen? Well, I guess, what should happen? What should the method return back to me? I would argue just should send back an empty array. If you give it an empty array, tell it to sort it, it gives you back an empty array. But I suppose the answer to this question mark here would be, well, what does the specification for the method say? And if the specification for the method isn't specific about that use case, then you ask whoever wrote the specification, well, what do you want the method to do in this particular scenario? And then we go back and we update the specification for that method. And now we've got a clearer specification. Therefore, we can write our particular test for that, because the specification will now tell me what exactly the method should do. Maybe the specification is going to say, well, it should return undefined or null, right? In which case I make sure I write my tests to make sure that it does return null or undefined. Or maybe the specification says it should return an empty array. And then I write my tests to make sure that it does return an empty array. So as I said a while ago, it goes back to, you know, if you can't finish one of these, then the problem is in the specification. It's unclear. And you go back to that. Hence, you're writing your tests against the specification. Now let's focus in a little bit on unit testing and the automation of unit testing. So some of the stuff that we've covered up to now is kind of generic. but obviously the generic can be applied to the specific. That's the whole point of it. So everything I've talked about so far now is still relevant to the end goal of being able to write good tests, whether it be unit, integration, or system. So in order to talk about unit testing, let's try and work on something tangible. And this is what you will be doing in the labs. So I'm just checking my watch. Okay, I'm okay on time. It's a very simple, we've got to start with simple test use case, I guess. So if I just flip over to VS Code. Again, if people have any questions, just don't be shy in speaking out. That's the way we'll try and work it if we can. So this is what you will be working your way through on the lab. I'm not sure if we get enough covered for next week's lab. If not, then I'll come up with another exercise for you. But for now, anyway, so we've just got a simple little project with a source folder and a test folder. The source folder, you can actually ignore these two. These are the two main classes. Actually, I've implemented them as classes. I have a product class, which is very trivial. Like there are cases where you don't need to write a test for a class. And clearly this is one example of it because this class just has a constructor. But it's a class Maria representing a product. That's the context. So nothing interesting there really. And then my second class is a catalog class. And its constructor, it's obviously representing a catalog of products. So here's its constructor. The catalog has a title and the catalog has an array, and presumably the array is going to be an array of product objects. And I've got lots of methods. I've got a method that checks to see if a particular product is in the array based on the product ID. Another method that allows me to add a product to the catalog. I first of all check to make sure that there isn't a product in there that has the same ID. I won't allow that. And there's lots of other methods as well. We don't need to go into the detail of them now. You'll be doing that in the labs. So this is the class that has a lot of stuff going on in it, and clearly it's going to be the one that we want to test to make sure all of the methods are doing what they're supposed to be doing. So we have our product catalog JS class, and as I said, as you've just seen, it has a find product by ID method. Now, arguably, or admittedly, it's a simple method, but this is a specification for that method. And again, there are no surprises in there. I've got a find product. Oh yeah, so let's say I want to test that method. So that we would say that method is my target, my test target. And these are clearly two test cases for that particular method, or two tests that I need to implement, and I've expressed them using my given when then. Now, I'm not going to be, if you're kind of thinking forward now, I'm not going to be asking you to write these kind of English statements at all, but you kind of need to kind of work them out in your mind, I suppose, rather than anything. Just want to make that clear to you. Really what we want to focus in on is writing or implementing tests and following whatever kind of coding style that is required based on whatever testing framework we're going to be using. But these are two sensible test cases for my particular method. And there are probably only two really, because it is admittedly a trivial enough method. Now, if testing frameworks didn't exist, then what would we do? We'd probably have to go away and write a a simple JavaScript script file and do it that way. That's what I mean by custom automation here in the title of the slide. And you'd find fairly quickly that writing automated tests using this custom approach really breaks down very quickly, because your JavaScript script file is just going to grow longer and longer and more unwieldy and difficult to maintain, because it is code after all, and you're going to have to maintain it and amend it, and it becomes very unmanageable. And that is the way things were before testing frameworks came on the scene. They weren't there from the outset. And it's something that I actually may get you to do in next week's lab. I'll get you to follow the way that we shouldn't do it, but it will enlighten you as to why testing frameworks are so beneficial. It's a worthwhile exercise at the same time. That's what I'm thinking right now as to what I will get you to work on in next week's lab, because I don't think I'm going to have enough covered in this week's lecture to allow you to use proper testing frameworks, but you will still learn a lot from next week's lab. So this custom script approach towards writing your automated tests is not worthwhile or rewarding. Hence, we need to use some sort of framework, testing framework, to do it for us, to help us. And every language, every programming language has unit testing frameworks. I'm just going to ask, actually, have you come across the JUnit testing framework? Because I have a sense that it has been covered, maybe briefly, but at least it has been covered in maybe a software engineering module that you might have done in second year.
Briefly, yeah.
Yeah, briefly. Okay, that's worthwhile though. So you have a sense of what this is all about, which is great. And I had a sense of that anyway. I wasn't saying they know nothing about unit tests. I had a sense that you had that. So yeah, C# has its own testing frameworks. There are many of them really. JUnit is not the only Java-based unit testing framework, but it by far and away is the most popular one. Because we are doing everything in this semester in JavaScript, then the dominant one in JavaScript is a framework called Mocha. And that's what we're going to be focused on. And anything that you've learned in JUnit, because all of these unit testing frameworks, they do follow the same style of programming, if you like, of implementing your unit tests. Arguably, I think JUnit was probably one of the first ones to come on the scene, and the other ones kind of followed suit. But anyway, we're going to be focusing on this Mocha framework. And no matter which language unit testing framework that you use, they all thereabouts have the same kind of feature set, and that really harps back to the point that I just made, that JUnit was the first one, and the other ones tended to copy what JUnit offered. So they're all about facilitating good structure of your unit testing code. It's very important to structure the code properly, because if it's unstructured, then it's very difficult to maintain, and you do have to maintain your testing code. And it's also very difficult to arguably understand or read the testing code, because it's quite likely that somebody else will be reading your testing code and they need to understand it. These testing frameworks provide a way of expressing tests, test outcomes and expectations, and I talked about expectations a while ago. And they provide, they allow you to, sometimes you want to run one particular test, sometimes you want to run a subset of your tests, or you want to run all of them. And the testing frameworks allow you to express those from the command line. So the Mocha framework is where we're focused on, and it provides, I'm saying, an execution environment for automated JavaScript tests. Now, from So we are going to be writing our testing code using this Mocha framework. And what are the main constructs that we need to be aware of? These are the constructs that we are going to be using in our code. So there are 3 constructs, and these constructs are actually reflected in JUnit as well, if you kind of dig out your JUnit notes from whenever you covered it. So there's these thing called describe blocks. This is all a bit abstract now, but when we start to actually use it, hopefully it will make a little bit more sense. So there's describe blocks. That's one construct that we use. There are it blocks, another construct, and there are before and after hooks. These are the 3 constructs that we are going to be implementing in our tests. I'm saying that each test case, so a test case is equivalent to that one of those given, when, then statements that we had a few slides back. Each test case is wrapped in an it block. Okay, so we're going to have an it block of code for every test case. We wrap the it blocks that relate to a particular aspect of your unit. So we might have a number of it blocks for a particular method. And those it blocks would be wrapped inside a describe block. The describe block may also have a before and after hook associated with it. And you can nest describe blocks inside other describe blocks. That's the structure. Maybe this would make it a little bit more meaningful. This is an excerpt with some detail taken out for obvious reasons that don't want to clutter the screen too much. This is the kind of code now that you are going to be writing for your unit tests for JavaScript targets based on the Mocha framework. So here's a describe block, what I'm calling a describe block. It's really, that's just a function that takes 2 arguments. The first argument is a string, and inside that string, you express the nature of whatever target you are testing. So let's supposing it's a class name. The second argument is a function. Inside this function, we have a before each block, and then we have another describe block, and finally we have our it blocks. It all looks very confusing when you just see it for the first time, but take it from me, it will make sense once you start to practice these things. So we are talking about unit testing now at this moment, right? So unit is, let's say, a class. Let's keep it simple. And a class has many methods. So I am going to have one of these describe blocks for each method. Those describe blocks are going to be nested inside the describe block for my class. The describe block, the outer describe block, is going to have a before each block. And the idea there is that inside there, we would put the actual code relating to the given part of your given, when, then test case. In the describe block for a particular method, we are going to have an it block for each individual test case for a particular method. And assuming that the class has many methods, then we're going to have another one of these describe blocks down here, and many of them. The syntax is quite clumsy initially, but you just get used to it. It's this idea like of having functions buried inside. You've got functions buried inside in lots of places. Now, I'm conscious of the time, and I've actually gotten as far as I expected to get today, but we're still, we've still only just touched on this, and it's this kind of code now is what you are going to be writing throughout this module. Actually, for every aspect of testing that we're going to be looking at, whether it be unit testing, API testing, or end-to-end testing, this structure is going to reoccur in each of those cases, even though we're going to be using different frameworks for each of those particular levels of testing. They actually all follow the same structure. And that's kind of beneficial because we only need to grasp and understand the structure once, and we get to reuse it in different aspects of testing, different levels of testing. So I'm going to halt the lecture there. We're about 5 past according to my clock, or maybe a little bit early, but there's no point in me trying to rush through stuff because this is a critical stage now in this topic.